Good afternoon, and welcome to an overview of factoring polynomials, lesson 8.6. So we're going to be factoring polynomials today by using synthetic division, except a slight shorthanded form version that requires you to do a little bit of that math in your head. Now, in order to determine whether a binomial is a factor of a polynomial, that binomial must result in a remainder of 0 when divided into the polynomial. So anytime we get a remainder of 0, we know we have found a good factor. So let's take a look at example 1. So we have the equation f of x is equal to x cubed minus x squared minus 16x minus 20. Now they've already given us one of the factors, which is x minus 5. We're going to start by writing out the coefficients of the terms of the polynomial at the top of our problem, or the top of our little box here. As you can see, the coefficients of 1, negative 16, and negative 20 are already written at the top. To synthetically divide, we're going to take the x minus 5 and divide by the root, which is positive 5. So this is going to require a little bit of mental math here. Now in synthetic division, we always drop down the first term. So I'm going to drop down the number 1. Okay, from here, I'm going to multiply 5 times 1 is 5, add it to negative 1, and we're going to get positive 4. Now we're going to repeat the same process again, but this time 5 times 4 is 20. Add it to negative 16, and you end up with positive 4. And again, 5 times 4 is 20. Add that to negative 20, and we get a remainder of 0. So this awesome remainder of 0 is an indicator that 5 is a root of the polynomial. Okay, so one factor down, we have 2 more to find. So the reason I know that I have 2 more factors to find is that in this polynomial, I have a degree of 3, since the highest valued exponent is 3, and that degree indicates how many factors you should have. So a degree of 3 means I should end up with 3 factors at the end. A degree of 4 will mean I will need 4 factors at the end, and so on and so forth. Now, to figure out what term I should divide by now, or what binomial I should divide by now, I'm going to look at this final constant number, so 4. And I'm going to have to identify what are some possible factors of 4. So some possible factors of 4 are 1, 4, 2, negative 1, 4. And this is where a little bit of educated guessing comes into play. We're going to try some of those factor numbers to see if any of them result in a remainder of 0 when divided into 1, 4, and 4. So I'm just going to try 2. And again, we're looking for a remainder of 0, but this time underneath the second 4. So our first step will be to bring the 1 down. I'm going to multiply 2 times 1 and get 2. And then when I add that to 4, I get 6. And I'm going to do that again. Multiply 2 times 6, which is 12. Add it to 4, and this time I get 16. Did that result in a remainder of 0? The answer is no. So that means 2 is not a workable factor. So with that in mind, let's try its opposite, negative 2. I'm still going to drop down the first term of 1. Now, negative 2 times 1 is negative 2, plus 4 is positive 2. Now again, we're going to do negative 2 times 2 is 4, plus 4, or sorry, say that again. Negative 2 times 2 is negative 4, plus 4 is 0. So, dun da da da, This time we ended up with a remainder of 0, which means -2 is a perfect answer. So now, based on our check marks, I know that I have two factors. I know that y is equal to x minus 5, because if the root was positive 5, the factor is negative x minus 5. And then the next one I have is x plus 2. Now, so far in this problem, we started with a degree of 3. When we divided that out, we ended up with a degree of 2. And so our final two terms are a result of a degree of 1, which is the same as a factor. So this, 1 and 2, result in our final factor of x plus 2. Now, if you notice, that is the same factor as the factor produced from this root, which was x plus 2. So when I write it in factored form, I'm just going to put x plus 2 squared to indicate that x plus 2 is a factor that appears twice. So now we're going to look at graphing our factored form of y equals x minus 5 times x plus 2 squared. So the first thing I need to do is graph my y-intercepts, which are 5 and -2. Now in each of these, we need to talk about root behavior. For the x minus 5 factor, since it has a degree of 1, we know it's going to be a linear pass-through. For the second factor, x plus 2, because it is squared, we know that it's going to have a quadratic behavior, which means it's going to produce a bounce. We also need to identify end behavior, which we can find looking at the term of highest degree, which in this case is x cubed. Since that is a positive coefficient with an odd degree, we know it goes down, up on the graph. So when I graph this, I'm going to start down, create a bounce at -2, and a pass-through at positive 5. And there's our graph. Now, I will say that mine kind of went a little bit past the x-axis, which it shouldn't have. Fun part about writing with a stylus. Okay, and that is example 1. Okay, moving on to example 2. This time we are going to factor f of x is equal to x to the 4th plus 5x cubed plus 5x squared minus 5x minus 6. Now, I know just by looking at this problem that it's going to have 4 factors because its highest degree is 4. So let's start by writing this out on our little table here. We have 1, 5, 5, -5, and -6 is what we're dividing into. And since they've given us the factor of x plus 2, I know that I'm going to divide synthetically by -2. We're going to start by bringing down the 1. -2 times 1 is -2, plus 5 is positive 3. Ooh, wrong color. Should just erase, right? Except I'm not doing a very good job of erasing this sucker. Doesn't agree. Okay, well anyway, we know it's 3. Let's move on. -2 times 3 is -6, plus 5 gives us -1. And then -2 times -1 is positive 2, plus -5 is -3. And then lastly, -2 times -3 is positive 6, plus -6 is 0. So again, dun, da, 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 we know that this is a factor because our remainder was 0. So I can write the factor for that root as x plus 2. So now we have to give another one a try. I know that the terms I have remaining are 1, 3, -1, and -3. I'm going to use factors of this last term to see if I can come up with additional values. So factors of -3 are 1, -1, 3, and -3. I'm going to start with 1 and see if that ends up working. So starting first by dropping down the first term of 1. 1 times 1 is 1, plus 3 gives us 4. 1 times 4 is 4, plus -1 gives us positive 3. And then lastly, 1 times 3 is 3, plus negative 3 results in a remainder of 0. Yay! There we go. Proven that it's another factor because its remainder was 0. So that means the resulting factor with a root of 1 is going to be x minus 1. So now we're going to try again. So we still have 3 terms remaining. We're trying to get it just down to 2 so that we have just a binomial remaining. So I'm going to look at factors of 3 in order to determine what numbers I should try. So I'm going to give the number 3 a try and see what happens. Start by dropping down my leading coefficient. 3 times 1 is 3, plus 4 is 7. 3 times 7 is 21, plus 3 is 24. Oh, that did definitely not leave me with a remainder of 0. Okay, so that means 3 doesn't work. Let's try negative 3. Again, drop down the 1. Negative 3 times 1 is negative 3, plus 4 leaves us with 1. And then this time, negative 3 times 1 is negative 3, plus 3 gives us a remainder of 0. Yay! Third root found, which is x plus 3. Now, since we did end up with 2 terms remaining at the end, this is indicative of the binomial x plus 1. And so that serves as our fourth and final factor. So when we come to graph it, we identify that our y-intercepts then are negative 3, negative 2, negative 1, and positive 1. We also know, since each of these factors has a degree of 1, that they are all going to be linear root behaviors. The end behavior, which is determined by the leading factor here, which is x to the fourth, the highest power degree, since it has a positive coefficient with an even degree, we know, based on what we did back in 8.1 and 8.2, that the end behavior on this particular one is going to be up, up. So as far as graphing goes, I'm going to start up, and I'm going to pass through negative 3, 2, negative 1, and I'm supposed to pass through 1 to get my final answer. There we go. Okay, so those are the first 2 examples on how you factor when given at least one of the factors. Okay, taking a look at our next slide. Here we go. So we're going to do the first 2 on 4 and 5. So starting first with our synthetic division, we are going to be dividing x cubed plus 2x squared minus 8x. So our coefficients are going to be 1, 2, negative 8, and then I'm going to put a placeholder for the constant of 0. Now in this one, since they didn't give us a factor to start with, this is where our educated guessing comes into play. Our final term in this equation is 0. So we're going to start with the factors of 0, which in this case happen to just be 0. So we are going to synthetically divide this polynomial using the 0 term. Start by dropping down the 1, and 0 times 1 is 0, plus 2 is 2. 0 times 2 is 0, plus negative 8 is still negative 8. And then from here, 0 times negative 8 is 0, plus 0 is again 0. So that means the factor of x is a factor of this polynomial. So next we're going to look at reducing our 3-term polynomial down to a 2-term polynomial by looking at possible factors of negative 8. Again, I usually start on the lower side when I'm working on factor numbers, just while 8 and negative 8 are definitely possibilities. Usually working on the lower end affords you a little bit more success. So I'm actually going to try the number 1 first. Dropping down a 1, 1 times 1 is 1, plus 2 is 3. 1 times 3 is 3, plus negative 8 is negative 5. So that one definitely didn't work because we ended up with a remainder of negative 5. Okay, so let's try another one, negative 1. Dropping down a 1. So from here, we're going to start with negative 1 times 1 is negative 1, plus 2 is 1. Negative 1 times 1 is negative 1, plus negative 8 is negative 9. Again, 1 where the remainder was not 0, so that doesn't work as a possibility. So, let's see, this time let's try the number 2. 2 is also a factor of negative 8. So again, I'm going to start by dropping down the 1, and I multiply 2 times 1 to get 2. When I add it to the other 2, I get 4. And then for our last slot, 2 times 4 is 8, plus negative 8 is 0. Yay! So we found another factor, which means we're going to have the factor x minus 2. Now that we have divided everything out synthetically and are left with 2 terms, we have identified our final factor, which is x plus 4. So the factored form of this polynomial is x times x minus 2 times x plus 4. So when we look at graphing that on our graph over here, we're going to have x-intercepts at negative 4, positive 2, and of course 0. All of these are going to be linear behaviors because they all have exponents of 1. And then for us, since we have a highest term degree of x cubed, the end behavior is going to be down, up. So when I start on the downside, I'm going to linearly pass through negative 4, 0, and 2 to end up with our graph. And lastly, number 5, f of x is equal to negative x cubed plus 4x squared. Definitely missing a significant number of terms here. So we're going to synthetically divide negative 1, 4, 0, and 0. So we needed a placeholder for 2 things. We needed a placeholder for the degree of 1 and the degree of 0. Now, since we have a factor of 0 here at the end, I am going to use factors of zeros to synthetically divide. Well, thankfully there's only one of those, so we're going to divide by 0. Start by bringing negative 1 down and multiplying 0 times negative 1, which is 0, plus 4 is 4. Oh, didn't quite finish that 4. Okay. 0 times 4 is 0, plus 0 is 0. And then 0 times 0 is 0, plus 0 is, again, 0.